Assalamualaikum, Doctor. This is Group 2, presenting you about neurophagy system on temperature control. So we have 3 group members. One is Azrah binti Haizrul Izwan. Second is NURIZAZI binti ZULKIFLI. And me, myself, is NURFAQIHAH ZAHIRAH binti ZAINAL ARIFFIN. So this is the table of contents in our presentation today. We have the introduction, the background of application, the methodology, the benefits, the conclusion, and also the references. So let's start with the introduction. So the artificial neural network, ANN, and fuzzy logic is a hybrid that combine to create neurofuzzy system, NFS, which has been successful despite some early drawbacks. Adaptive neurophagy interference system is a powerful tool for temperature control due to its self-adaptive nature and also control function. It's very effective in predicting and optimizing temperature variation and can be used in various applications, including controlling nonlinear processes in practical industries. So, what is neurophagy system? So, a neurophagy system combines artificial neural networks and learning ability with fuzzy logic systems, human-like reasoning, creating a versatile tool that enhances adaptability and decision making. It's very effective in various applications such as temperature control and its predictive modeling, due its ability to learn from data and handle uncertainty. So this is the background. We'll be discussing and presenting to you 4 major backgrounds from the topic today. So the first one is the evolution of artificial ANN. ANN have had a profound impact on diverse fields, including temperature control. A significant milestone in the field was Sabenko's 1989 demonstration of the universal approximation capability shaping and landscape of machine learning application. So the second background that we are presenting to you is overcoming setbacks and advancements in multi-layer ANN. So the setbacks highlighted by Minsky and paper 1 in Perceptrons 1969, spurred advancements in the 1980s, introducing algorithm for training multi-layer ANNs. Multi-layer ANNs emerged successfully, addressing challenges posed by intricate tasks such as the exclusive OR functions. And number 3 is integration of ANS with fuzzy logic in temperature control. The system of artificial network with fuzzy logic is exemplified in adaptive neurofuzzy inference systems. ANFIS, known for self-adaptive nature and integration of control functions, stands as a valuable toolbox in temperature control application. And the last one is number 4, practical application and ongoing refinement. ANFIS has proven successful in practical application related to temperature prediction, showcasing its effectiveness in controlling mean monthly temperatures. The the conti the continual refinement and integration of ANN and fuzzy logic underscore the pivotal role in advancing machine learning capability for precise temperature regulation.
my name is Azrah, and I'll be presenting the methodology for this system, for this ANFIS approach. And the daily for this approach, the methodology is using the daily dew point temperature, predicting the DPT using artificial intelligence technique by employing the ANFIS, that is the adaptive neural fuzzy inference system method. So that the main focus is on using ANN, the artificial neural network, as the controller for the system. So the first step is using the input parameter of the membership function to make up the initial layer. And from in this slide, the input parameter is the Tmax, Tmin, and Tmean. And for this layer, this then uses it into the second step, and second step is putting the input parameter into the equation. For the third step will be the rule layer. The rule layer will where the nodes will indicate the normalized weight. The equation is beside here, beside the third step. The W initialized equals to W initialized per sum of the weight initialized. So the fourth step will be the layer that responsible for the defuzzification, and in this layer is the if-then layer. This where if-then rules is applied, and so this the equation beside it is the reference to the if-then rules. This will be the schematic for the model for data training and testing. In here, the membership function characteristic will be in this design in the model, and then the model will be then data selected for the training and testing, and then the training and testing will be done. After that, it will get the prediction for the process and compare, and if the outcome is the accuracy is less than supposed to, they will run this again to get the best outcome and best accuracy. The next step is the using the input parameter into the ANFIS approach. Is this approach that looks like an ANN model. So there will be 3 inputs in this approach, and then in the system there will be 3 input, and in each input there will be 6 membership function, and input 1 input 2 and input 3, and then there will be output for 216 rules, one output. In this next slide will be the degree of membership function for input 1 and input 2. For input 1 will be the T mean and the minimum, and the input 2 will be the T maximum. Last in the methodology will be the evaluation for the data that have been gathered, and for this one, the first one is the evaluation on the training data, and the second one will be the evaluation on the testing data. Lastly, this one is in this slide will be the evaluation on the prediction mode that is compared to the observed mode. Above is the prediction mode and below is the observed mode. That's all for methodology. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm NURIZAZI binti ZULKIFLI S6191. So I will explain about the benefits of the neural fuzzy systems. So what is the benefits of the neural fuzzy systems is a rule-based control that involves rule-based control where the fuzzy rules define the relationship between the input variables and control actions. Furthermore, it is a Henry uncertainty that introduce the uncertainties and imprecise data. It enable the system to handle such uncertainties and make the reasonable control. Next, it is a linguistic representation. It is the representation with the neural network's learning capabilities. It is providing an intuitive framework for the expressing complex rules. I also have some research on the benefits of artificial neural network. So it is a nonlinear mapping, and adaptive learning. That's all.
So to conclude the whole presentation, basically the use of AI, specifically ANN and neurophysics system, had shown promise in temperature control mechanism. Studies has demonstrated the effectiveness of these two hybrid neurophysics networks for adaptive temperature control and the prediction of daily dew point temperature in Tabriz. The neurophysics system proves that it is reliable and flexible in managing nonlinear relationships, adapting to dynamic temperature changes and accommodating system uncertainty. The practical implementation of NFS has shown effectiveness in real-world temperature control application. So this is our main reference. We have more than three reference, but this is the three that we have used to gather information about the topic we are discussing today. So that is all from Group 2. Doctor, we are grateful that you are our lecturer, and we thank you for doing what you do. Uh, we wanted to say thank you for making this class very interesting and interactive. Thank you so much for this semester, Doctor. Thank you.